We have one more example of a piecewise function that we're going to work through together, exercise 14. Let's go ahead and graph f of x equals -2 if x is less than -1, x minus 1 if -1 is less than or equal to x is less than or equal to 2, and 5 minus x if x is greater than 2. So from the previous examples, we've seen that we can work with pieces separately first, and so you can do it that way, or if you prefer to go right to the final graph, that's fine with me if you get what's going on here. But I'm going to do this one again where I draw some preliminary graphs that I put together to construct the final graph afterward. And so now we have three pieces here, so we're actually going to have pieces of three different functions. And that first line has just a -2. Sometimes people are thrown by this -2 all by itself. But keep in mind that each of these expressions right next to the brace stand for equations of the form y equals that thing. So we actually have y equals -2. Y equals -2 has a graph that's a horizontal line that passes through -2 on the y-axis, so it's the horizontal line y equals -2. And we want only a portion of that for our final graph though, right? We only want the portion when x is less than -1. So we want a piece of it over here. We don't want it when x is equal to -1, so we're going to draw an open circle and take everything to the left of that. That open circle has coordinates -1, -2, so we got to be aware of that. All right, now in the middle example, we're graphing y equals x minus 1. So that's a straight line with y-intercept -1 and slope 1. So I'm just going to draw that in pencil before I decide what part I want to use. So here, actually at my y equals -2, below that I want to write x less than -1. Y equals x minus 1. We're taking the piece of that graph between x equals -1 and 2 with the endpoints included. So when x is equal to -1, we have this point right here, and then we're going to go to the right until x is equal to 2. So we get this point right here. That's the point with coordinates, what is that, 2, 1. And this is the point -1, -2. So we have this stretch of that straight line that we're going to use in our final graph. And then to the right we have another straight line graph because we're going to work with y equals 5 minus x when x is greater than 2. So first let's just draw y equals 5 minus x. That has y-intercept 5 and slope -1. And you can draw that using whatever technique you know. I'm just plotting some points because I know the slope here. So this is 5 units up. I think this is probably going to be 5 units over where I get an x-intercept. Now we only want the portion of that graph when x is greater than 2. So here's 2. We don't want to actually include the point right now, 2, 2, 3. So I'll leave open circle. But we want the portion of the graph to the right of that. Okay, so I got three pieces here. Now I got to put together to construct my final graph. graph. So let's go ahead and do that below. First I'll take the horizontal line. So I want to be aware of where this point -1, -2 is, or -1. I'm going to write on this side of the axis there. So -1, -2. At this moment it looks like open circle straight to the left. Okay, that's the piece of the horizontal line that I use. Then I'm going to take this stretch of the x-1 line, and notice I now have to fill in -1, -2, because that is a point on my graph. I'm going to go right up to the point 2, 1 and color in this point on the graph. So if you're wondering, in my final graph, do I have open circle or closed circle? Well, you have a closed circle if the function is actually, I guess I wrote the function description down here underneath, if the function is actually described to have that value. So at -1, yes, the function really does have the value -2. I need a closed circle there. At 2, I have the function value 1, so I need closed circle there. Now I need to add this portion of the 5 minus x graph. So now this point with the open circle is actually 2, 3. Correct? Y coordinate is 3 there. So 2, 1, 2, 3 is up here. I need an open circle, and then I need to draw my line down to the right. Okay, so this is the point 2, 3. It's not actually a point on my final graph, but I need to indicate it because I need to have that little stretch in between 2 and 3 drawn, and that helps me get my stretch between x equals 2 and x equals 3 in its correct position. This point right here that I colored in is the point 2, 1. So that's the actual function point on the graph, because the y value is 1 there. But as soon as we get greater than 2, we jump to that other line. So there it is. Notice that 2 of the pieces are connected, and yet there's also a piece that's disconnected. We got some closed circles and some open circles that we have to get in the right position to get this graph drawn, this triple piecewise function. And we're through.